Okay, so prime numbers are numbers that have only two factors, meaning two numbers are the only thing that goes into it. So itself and 1. So there has to be two factors, meaning 1 is not a prime number because it's only got one factor, which is 1. 2 is 2 times 1, and that's the only way I can multiply to get 2 is 1 and a 2. So that is a prime number. It is the only even prime number because any other even number 2 will go into as well. So I have a little trick that I use for finding my prime numbers. I actually don't memorize them. I really work with my factors and my multiples. So it's called the sieve of Eratosthenes, and it starts with using a number chart. It could be a hundreds chart or smaller. I'm just going to go up to 50 because my numbers are all below 50. So the way that it works is you take and you start with, first of all, I know 1 is not a prime number, so I'm going to cross out my 1. The next number is my first prime number, and I circle it. So, and then I cross out everything else that is a multiple of 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I should have done this in advance. Okay, so I'm going to get rid of all of my even numbers that are after 2. And then the next number I have is my next prime number, and that's a 3. And now I'm going to get rid of all of my multiples of 3. You can count, or you can, if you know your multiples of 3, you can count by 3s. Otherwise, you can go 1, 2, cross out. Now, some of these numbers are already going to be crossed out. Some aren't. So it doesn't matter if they're still if they're crossed out already. They're still staying crossed out. You can cross them out twice. You can do what you want with it, but we're going to get all of our multiples of 3. All right. All right. And then circle your next number that you see is going to be your next prime number. And now we're going to get rid of all the multiples of 5. They could have been crossed out already. If they haven't, you're going to keep going. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. All right, next prime number is 7. Okay. And then I keep looking. My next number that I have is 11. So that's my next prime number. 11, 22, 33. Okay, and now we're starting to get more things crossed out. So then 13, 26, 39, and yep, 17, 17 to 34, 19. Okay. And there we go. So, is 2 a prime number? Yep. Is 13 a prime number? Yep. Is 24? Nope, it's crossed out. 27, it's crossed out. 28 and 29 is a prime number. So that's the easiest way I do it. Some of the prime numbers I have memorized, but anything bigger, I usually have to do process of elimination with the sieve of Eratosthenes. All right, so when we're talking factors, next thing we're going to do is factors. So factors are all the numbers that break into it. Some people think of these as those factor trees. We can get it down to prime numbers. So if I'm thinking factor trees, I'm saying what, just any factors that go into 125. I know 25 goes in there, and I actually know 5 goes in there. So 5, 125 or $1.25 is really 5 quarters. So 5 times 25, if I can write. Okay, and 5 is a prime number, so that doesn't break down anymore. I can break down 25 is 5 times 5, and there's prime numbers. So this is all the prime factors. If I really want all of the just factors of 125, I usually start with 1 and 125. And then I ask myself, does 2 go into 125? No. 3 does not go into 125 because if I add up those digits, I get an 8, and 3 doesn't go into 8. 4 doesn't go into 125. 5 does. And 5 times 25. And then 6 doesn't because 3 didn't. 7, 8, 9. And this is all of my factors. These are when they want all the factors of 25, and I keep going. Okay, if I want all the factors of 72, so these are prime factors. These are all the factors. Okay, so write all the factors of 72. So I'm going to start with 72. So 1 and 72. Does 2 go into 72? Yep. 2 and 36. 3 goes into 72? Yep. 3 and 24. And you could actually have to divide it out on the side. That is not a sign of weakness. That is a sign of you don't want to make a mistake. 4 goes into 72, yes, because if a 2 does, this is even. So double this, half this is 18. That's a little math trick that we do. 5 does not go into 72 because this is not a 5. It does not end in a 5. 6 does because 3 and this is even. So 6 and 12. 7 does not go into 72. 8 does, and it's 8 times 9. The next number I would try would be 9, and I already have it. So these are all of my factors of 72. Okay, so when I'm talking write numbers as a product of prime factors, that's what I really want to do, like this factor tree. Okay, so I can start with any factors that any numbers that I know multiply to get to 100. So 100 is, I need a pen. I think 10 times 10. And now, can I break 10 and 10 down? Yep, 10 is 2 times 5. 2 is a prime number, so I circle it. 5 is a prime number, so I circle it. And 10 here is 2 and a 5. And they're both prime numbers, so I circle it. So when I'm listing something as a product of prime factors, I have my prime numbers, which are 2. How many of them do I have? Which is 2. And then 5. And how many 5s do I have? 2. So this is 100 as a product of prime factors. All right, 72, doing the same thing. I can break it down into, I usually think of 8 times 9 is 72. All right, 8 breaks down, times 2 times 4. 2 is a prime number. 4 becomes 2 times 2, and those are 2 prime numbers. 9 is 3 times 3, and 3 is a prime number, and 3 is a prime number. So writing it as a product of prime number factors, I have a 2, and there are 3 of them. And I have a 3, and there are 2 of them.